This is a summary of CERTIT Project ER 2419, High Resolution Delineation of Contaminant Concentrations, Biogeochemical Processes, and Microbial Communities in Saturated Subsurface Environments. The project was led by Andrew Jackson at Texas Tech University with support from Haley Schneider, a graduate student who received her PhD on the project, and Dr. Stephen Morse, who's now at Michigan Tech, and Dr. Paul Hetzinger and Greg Livorno at APTEM. The project was focused on developing a sampler that was able to better evaluate the heterogeneity in subsurface saturated systems. Subsurface saturated systems are often very heterogeneous. They have very differing hydraulic conductivities in thin layers, and the fate and transport of the chlorinated solvents is highly impacted by these heterogeneous systems. Those systems cannot really be evaluated well by traditional monitoring techniques. Wells preferentially pull from the most permeable layer, and while there are a number of other tools out there, none of them are able to fully evaluate the subsurface system for all of the parameters that would need to be measured. Our technical objectives were to be able to directly measure groundwater and contaminant flux at the centimeter scale, to be able to quantify the biogeochemical conditions at the same scale, and to assess microbial community structure and activity at the centimeter scale. We also wanted to do this with a direct drive device that was reasonably simple to use, didn't need specialized training, and could be driven to at least 30 feet below ground surface. The project was successful in developing a direct drive passive profiler, high resolution passive profiler, that was able to measure at 20 centimeter resolution, so a sample every 20 centimeters, the concentration of chlorinated compounds, whether those are ethenes or ethanes, and that could be expanded to any contaminant that's got a reasonable solubility. It can monitor dissolved gases. It can monitor geochemical indicators such as sulfate concentrations, nitrate concentrations, sulfide, dissolved iron. It also contains compartments to evaluate microbial populations using commercially available biostat beads. These beads can be used to evaluate the DNA of the bacterial population and the activity of that population by evaluating the compound-specific isotope distribution of the chlorinated volatile organic carbons. So the biostat beads can be evaluated for the delta 13C, allowing you to look at fractionation, which is an indicator of degradation. Finally, the samplers are also able to monitor pore velocity. The project developed a new technique to evaluate the ability to use a loss of a conservative tracer and correlate the mass transfer coefficient with pore velocity, which was successful. We've demonstrated that the device can be driven to greater than 30 feet below ground surface with commercially available probes such as the GeoProbe, and the preparation and sampling time is generally similar to other direct drive devices. We evaluated the sampler at 3 field locations. We compared the sampler's results with other typical instruments like the membrane interface probe, hydraulic profiling tool, well measurements, nested well measurements, cores, and our data returned from the high resolution passive profiler was similar to other traditional measures, but had better resolution with about the same sensitivity. Finally, we think that the high resolution passive profiler will enable better site modeling. It will facilitate remediation design, be able to evaluate natural attenuation potential or the need for bioaugmentation, and evaluate the success of remedial activities. If there's any other questions, you can always contact Dr. Andrew Jackson at Texas Tech University. Thank you.